Hello, everyone. I hope you are not too tired at the end of the day. My topic sounds a little bit strange, but I hope it will be useful for everyone. And I will give a lot of examples based on React Native code, but this topic should be interesting not only for React Native guys, but for native too, I guess. So let's start. At first, I would like to say several words about myself. I am CEO and principal software architect of a Ukrainian outsourcing company, WebbyLab, and I am in software development for more than 15 years already. And during this time, I did a lot of different projects and did projects for 5 companies from Fortune 500 list. And usually, I share some interesting experience from these projects. And this time it's a similar situation, but usually I start with a business case and later discuss a solution. Today I will do it in an opposite way, and we'll start with theory, and later we will switch to real case. So let's start. Here you see a classical approach of building application. It's a classical 3-tier architecture. We have our presentation layer. Our presentation layer, it can be mobile application, web application, any type of UI. We usually have application layer. It's a part which is like the name Backend, which contains almost all of our business logic. And we have database layer. Application layer is usually stateless if we want to be able to scale our application. So, and if we will look inside of database, we will see something like this. We have entities with relations. For example, here we see users with messages, but we can have products, orders, transactions, anything. So it's a classical relational database. And the question whether we can do it in a different way. Yeah, we can use MongoDB, and we will have here collections with documents with nested objects, but we will have some sort of relations too. It will be very similar. But can we do it in absolutely different way? And another approach, I will share it now. So let's. Before moving forward, usually we have an average 5 endpoints to manage our entities, like create, read, update, delete, nothing special. Or we can use GraphQL for that. So nothing special here. Here we have 3 endpoints that which will do writes and 2 endpoints for read. Okay. So let's assume that our data is not a set of tables, but a large append-only log, our database. And this append-only log contains huge amount of immutable facts, nothing else. So every application has log files on server, but we use them not for data, but for debugging, for finding issues with our backends, with production. But let's assume that this log file is a source of truth for our application, and the rest of the data is just a cache, nothing else. So we can delete the rest of the data if we have this log file. So here's how it can look like. We have log in the center, we have indexes, we have our applications, databases, and they are somehow related to this log file. And there is a name for this architecture. It's an event sourcing architecture. And let's take a look. A real case. It's small, but real. So we have this classical approach. We have a database, and we have users, and each user has a balance. And for example, we have a balance $100 at account of a user, and user spends $30. What we do? We read 100, subtract 30, and save $70. So initial DB state was $100, and now we have $70. It's a classical approach. How will it look like with event sourcing? With event sourcing, it will be absolutely different. So we have this log with events, and initial DB state is not $100, but set of facts. And if we will sum up all of the transactions, we will have $100. And if user spends $30, then we will just add another line to our log file. And in total, it will be $70. It's the simplest case. And of course, it's not very convenient to work with such type of log. Moreover, usually if you are working with money, you have table with transactions, and you already have some sort of event sourcing at your backend. But can we use it for other stuff? Like, for example, here we have a shopping cart. And what we see, we have several events here from presentation, cart created, item 1 edit, item 2 edit, item 1 removed, and shipping information edit. We have 5 events, and all of them were sent to our backend and persisted in an event store. After that, we can build materialized views. So we can build a materialized view for our shopping cart. And this materialized view will contain only 2 tables, one table for carts and another table for items. And what is important here is that we will have only one item in our shopping cart. So we will have only item 2 because item 1 was removed. And moreover, we can use this event store for different purposes, and other system can use this event store. So what are the benefits of such architecture? First of all, we can have different domain-specific materialized views. Here we have shopping cart, but we can use the same events for analytics, for example. Moreover, we capture not only result, but intent of the user. We track the behavior. So, for example, here we understand that at first item 1 was added, and later it was removed. Possibly, this user is interested in item 1, and we can suggest him this item later, for example. Moreover, if you build systems for pharmaceutical industry, healthcare, financial, usually you have a requirement to have audit trail inside of your application. You need a log of all actions performed by users. And with this approach, you already have it. So you need to do nothing. You just have it in your system because everything is an event. Moreover, you can roll back your state to any date, to any time. You can see what was in your shopping cart like 10 minutes ago, or what was your balance yesterday. And moreover, if you have some analytics, you can replay events. For example, you have you calculated some sort of metrics, and you see that there is a bug in your code, and you can fix your code and just replay all events and recalculate this materialized view with metrics. And this approach is much more performant because it's rather easy to store these events. You just append them, and it works with any load. The only thing that you will have, if the load is really high, you will have small delays in processing, but your application will always be able to make writes to your backend. Okay. So it's a theory. Let's discuss a real task. What was the task and what was the type of application? It was a learning management system for compliance, and we had the requirement for it was like web application, mobile application, and backend. And all of like web and mobile should work offline, not only for read, because if you implement offline for read, it's rather easy. It's just having a cache in your phone, and that's it. But the requirement was to be able to do writes in offline. So you can create comments, you can do anything with your application in offline, not only just consume data, but create anything. Another thing, audit trail support, as I mentioned before, detailed analytics, and every day we have new requirements for this analytics. And for this situation, event sourcing seems like a good match. So here's several screenshots from the mobile app. We have here several metrics like overall trading progress, expected time to left, actual left, progress burned down. We have discussions, comments, and all of this should work offline. And the same for web part. In our web application, we have more statistics, and we have burn down chart, activity chart, and a lot of other things. And this application contains training, and each training is a document and a quiz related to this document. And questions from this quiz are mapped to sections in document. So we can know which part of document students know better and which still require like more effort to study. So it's a screenshot from web part, and here is the list of metrics that we track, like adoption level, predict time to finish, spend time in training, monthly activity charts, aggregated metrics for groups, like training adoption word down chart, etc. Like a lot of different metrics. And every day we have new metrics to add. Okay. In our company, we use a lot of JavaScript, and in this case, everything is in JavaScript. We use React Native for mobile, React.js for web, and Node.js for backend. And it's a common, from time to time, it happens that you can reuse your business logic in mobile and web, because you have React and Redux on both sides. But for backend, it's unusual to use Redux, but we decided that it could be a good idea, and I will explain about why a little bit later. So yesterday I decided to add several slides about React Native and React, just to be sure that everyone understands what is React Native. And in several words, React and React Native is just like a template engine on steroids. So it's nothing special. You have your templates, you have placeholders, and if you have a template, like you have components, it's like part of your template. And if you want to update your UI, you can re-render the whole application, the whole template. And for example, if you need to change a label on a button, you change your data and re-render everything. And usually, with handlebars or other template engine, it will not work very efficient, but with React, it works a little bit different. React builds a representation of your UI in memory and stores it as tree. And when you update something, it has another copy, like updated copy of your UI, like components tree, and it calculates difference and does minimal amount of updates to real components. So it's rather performant. So if you will re-render everything in React, and after the render only one label on a button will be changed, then React will apply only one change to your real UI. And it works in this way for web, but in React Native, it's absolutely the same UI, absolutely the same React.js, nothing different, the same library, but it works in a separate thread. And in React Native, you have 2 or 3 threads and a bridge which connects these parts. So we have JavaScript part and our business logic in JavaScript, React.js in JavaScript part, and native part looks and like it's real native components. We send comments via bridge. So that's the idea of React Native. React Native is really cool technology for us. We use it. Who use React Native, by the way? Like, okay, several people. I guess more people will use it after the talk. So the key idea of React Native, not in JavaScript, but because it's like declarative, it's a framework for declarative UI. And before React Native, there was a component kit for iOS. Anyone knows about component kit? Okay, so it was a framework inspired from Facebook, inspired by React.js. And it works only for iOS, written in Objective-C. And Facebook uses it for parts of Facebook application where the performance is the most important, like key parts of the application. And there is the same framework for Android, Lito. So it's the same as React in Kotlin or something like that. Okay, so we have declarative UI. We have application state separated from UI. And in this case, we need a library to manage our application state. With React Native, we can reuse code between different platforms. We can have hot reload, code push. So rather interesting technologies here. Okay, so as I mentioned before, we need, who is using React Native? As I mentioned before, we need state management library for declarative UIs. And in React Native community, Redux is a choice by default. 90% of projects are written in Redux. So here is the idea of Redux. I will try to explain what is Redux in 1 minute. We have UI. UI triggers action. So we have action creator, which creates action and passes it, like sends, to reducer. Reducer is a pure function which takes state, applies change to this state using this event, and we have new state which will be in Redux store. And after that, our UI will be re-rendered with the new data. So it's one-way data flow, and I guess with code it will be more clear. So it's so here we have, I guess, 90% of API from Redux. We have what we have here. We have a function reducer which takes state, action, and returns new state. We have store which takes this. We have create store function which takes reducer and returns store instance. And we can dispatch different events like type increment, type decrement to our store. And the only requirement for Redux is every event should have this type. And you check this type in counter function and do some changes, return new state, and we have store.subscribe, and we have here console log, but in real application, you will re-render your UI here. So it can be any type of UI. It can be React, or it can be Angular, any type. You can use Redux with anything. So that's the idea of Redux. And why we call this counter function reducer? Because it's a function that we can pass to reduce. So I guess almost in every language there is a reduce method or fold method. And what we have here, we have array of actions. We call reduce on these actions. And we have this function that will reduce this list to one value. That's it. Okay, and let's look at event sourcing. What we have here? Here we have application write interface and application read interface. We have event queue, so we send our actions, events to this event queue, persist them, and we have event handlers, and we have derived application state and interface to read the state. So it's very similar to Redux, but we have some differences here. What is similar? So in both situations, we have events. In Redux, we call them actions. In event sourcing, we call them events, but it's the same. They are immutable, and both of them have types. Moreover, we have state of our application, and it's derived from these events. So, but we have some differences. In Redux, we do not have events queue, and our store is a source of truth for our application. So we process event, forget about it, and have everything in our store. In event sourcing, events is a source of truth for our application. And we can delete the rest because materialized view are just caches, as I mentioned before. In Redux, all reducers must be pure functions. In event sourcing, side effects are absolutely fine. And we have asynchronous processing in event sourcing and synchronous processing in Redux. So if we do several changes, we can combine these two concepts into one. So what we need to do? First of all, as I mentioned before, Redux does not have event queue. And we can edit, we can create temporary queue in our mobile application. It's the first thing. Another thing that we need to do is add timestamp to every event to make this event compatible with event sourcing. So, and that's it. It's for front end. For server side, we need to split our handlers with which work with which has side effects and with like split handlers into parts, like handlers with side effects and handlers without side effects, where we can use reducers because like we have pure functions, where we have our logic which we want to use from Redux. And we need to use immutable structures for the places where we use Redux reducers on server. Okay, so it should be easier to understand with this diagram. So on top we have client, mobile and web applications. On bottom we have server. We have event on upper left corner. And what we see is that we send this event to metrics reducers. Let me show, yeah. We send these events to metric reducers. Then we update our store, and that's it. It's like standard way how Redux works. But at the same time, we persist these events into our queue. And from time to time, we periodically submit these events to the server and save these events in persistent event queue on the server side. And we have event handlers here. And these event handlers can use the same reducers that we use on our front-end part. So it's the same code. Using these reducers, we can build the same state on our server and save it to database. So we have user metric store and group metric store. Sure, when a user logins, he or she will get state from the server, and later will apply events and update oven state here on mobile side. Okay, so it's a real application, and it's already in production and works in the following way. And after that, we have mobile offline mode for free. We need to do nothing to have offline mode which supports everything, because everything we do will be persisted in this event queue. And only one thing that we need is one endpoint on our backend to get these events, and that's it. And this will work for any type of applications, not only React Native, but for native too. Sure, for native you will need to have, you cannot reuse reducers, but you will have handlers on your server side, and it will work. Okay, so let's take that real code. So what we have here, several interesting parts. We use Redux async initial state library to load our state to Redux. We have here time for state to regenerate. So we periodically save state from memory to mobile phone. Okay, and if we have enough events, so we check here events length in our queue, if it's larger than events limit and our mobile application is online, then we just post these events to the server, and that's it. And these events can contain any information like create comment, create topic, update something, answer a question, anything. Here is example of event when a user clicks on a topic and event mark topics as read. And it's like standard event. As usual, we have type here, but we've added timestamp and we have payload. So all of the events are of the same shape. We have type, timestamp, and payload. Okay. And how can we use these events? It seems that like we have open training events and it can be useful only for front-end part. But in real, we can use these events for different purposes. For example, open training allows us to compute user's activity, how many times per day user opens the app or the training. And it's a real reducer that we use both on backend and on frontend and mobile. So we use the same code everywhere. Okay. And here is another, for example, another event, answer question. Usually when user answers question, we just know, okay, that he answered the question. But using this event, we can compute adoption level, we can compute required time to finish, we can compute adoption, burn down, anything. A lot of metrics we can compute using this one event. And as I mentioned before, every day we have new requirements and add more and more metrics. For example, sections adoption level. We can compute, you see this heat map, and it shows parts of the document that students studied better, and in red, parts that are hard to understand and users make mistake answering questions related to these parts. And we can build all of this just using this answer questions event. Nothing else is required. Because we have timestamp, we can calculate how much time does a user spend on every question, because every event has a timestamp. So it's a really powerful approach. Okay. And we use React Native FS for large blobs and React Native Sync Storage for Redux store. On server, it's very simple. So we have endpoint which takes list of events. And what is important here is that we load user ID and company ID from context. So to be sure, so we add this information to every event. And we know after that we know the source of event, and we just insert all the events in somewhere. In our case, we use MongoDB, but in real it will be better to, like, for future we are going to switch to Kafka. Okay, and for the whole applications, what we have only 1, 2, 3, 4, 5, 6, 7, 9, 10, 13 types of events, and all we need, so if we will implement this on our backend, then we can support offline mode for everything and compute any metrics we wish. And we have events handler worker, which starts on server. And at first, we usually fetch. So here we have saved events into database, and here we fetch fresh events, split them into groups, one metrics related, where we can use reducers, and another one is like other type of events, where we use custom handlers with side effects. For example, a comment created. We do not need client-side reducer here, we just added a record to database in our handler on server side. What is important here, so you have processed events and you need to mark them that they already processed. And how to do it? The most obvious solution that comes to mind is to set like a flag inside of event that is event is processed. But event must be immutable, and we should not do this because these events can be processed not only by one handler, but a lot of handlers. And instead, it's better to store reference to last applied event into your state, for example, in events metrics. As for code structure, we have 4 repositories, one for mobile, React Native, like both iOS and Android, for web, for backend, and repository with shared code, with reducers, and shared tests. So that's it. Yeah, there are issues to solve. Like as I mentioned before, we are going to switch to Kafka, create 2 queues, one for real time and one for delayed processing, and store a larger number of events in offline mode. Because if user is offline for a week, it's not a case for us, but it can happen. Then it requires more space, and we need to change our approach how we store a process event in mobile. There are several links, really useful links. The first one is an article from Microsoft, which describes event sourcing pattern in details. The second one, similar, from Martin Fowler, but from Microsoft, it's like better, a little bit better. And great talk about inside-out databases. It's a video, it's a third link. And the last link is a link from one of my software engineers, software developers, who was involved in this project. That's it. Thank you.